So these are the very basic steps that I want all of you to follow. If you want to do a phylogenetic, if you want to do multi-sequence alignment, then generate your clustering and of course your phylogenetic tree. You just follow these steps one after the other. So let me share my entire screen, and that will make my work a little bit easier. Okay, so I'm going to share where now my screen is being shared. So let me pull up, or let me say this. For you to be able to do proper multiple sequence alignment, you should be able to do some level of alignment before. In terms of multiple sequence alignment, we can actually align with DNA sequences, we can align with RNA sequences, and then protein sequences. So today we are going to do the alignment on protein sequences, and so that is going to be what we'll be using. You can also do the same thing. You can use the same process to be able to do a DNA analysis. You can use DNA sequences to be able to do the same alignment. And so I don't have the sequences as at now, so the process I'm going to go through, just follow the same process one after the other. First of all, we need to get our sequences ready. So in that case, I'm going to pull up my Google accounts here. I was sending an email, so let me finish up with that. And so I'm going to pull up so I want to go to any of the databases and then download the sequences. So let me go to uniprot.org. So, and that is opening. Of course, the network is not too fast, so you need to bear with me. So when it is opened, we are going to search for some sequences. And then, okay, so now we can just go into this box here, and then we search for the envelope, let's say glycoproteins GP160. This is a kind of protein we want to find out. We want to find out where these proteins are found, which organism contain this particular protein. So I'm going to search for it. I mean, you could search for any other protein at all you want and get the sequences. The most important thing here is how to be able to do the multiple sequence alignment. So now it opens. So you can see we have quite a number of them here. Then you can just select those that you want. So I'm just going to select a few of them. If I want to select all of them, I'll just click here, and so everything will be selected, but that will be too much for us. So we may just want to select, let's say, 5 of them. So I'm just selecting about 5, or how many are there? 1, 2, 3, 4, 5, 6, 7. I just selected 7. Let me add 1. We'll make it 8. So these are the proteins that we have selected their sequences, and we want to align them. Then what will be the next thing to do is to download. Come and click on download. When you come here, you will see a zip file. Compressed means a zip file. So if we click on download right now, it means that we are going to download it as a zip file. So supposing we were downloading everything, that way we would have used a zip file. That way it will be easier. But now there are just some few of them, 8 that we have selected. So we come and uncheck. So when we click no, it means we have unchecked the zip file. We go ahead and then download the sequences. And so as you can see, the sequences are downloaded and they are down here. So I'm going to open it up. So you see, these are the sequences. I open it up in my text editor. So from here, this what we have on top here is the name of the sequence, but the name is too long. So what I'm going to do, I'm going to edit part of the name out. But what you cannot do here is you cannot edit this prompt, this greater than sign here, and what is following, and then the number around here. That's the identity. So don't edit those parts. And then of course the name that is following, that's what you will leave as an identity of that particular sequence. So, but you can edit the rest of them just to make sure that you have a very clean what is set of sequences that you want to align. So if the names are long and you are doing the clustering, you won't be able to read the names. So that's why I'm doing this editing. You can edit it the way you want, but just edit in such a way that the name, what it would make sense. But if the names are too long, it becomes clumsy and you cannot actually read. That's the basic reason why we do the editing like that, like I am doing. So I will just come here and do the editing again here, and then these are the very basic and simple processes as to how to be able to do. So you might also download, if your sequences don't have all this what I am having, you don't need to do all these things. So I'm just, so now if it is finished, then you Control and S on your computer will save it automatically. Now when you close it, now your sequences are ready. What we have left is to now go and do the multiple sequence alignment. And to do that, we are going to use the Ubuntu or the Linux interface. So I'm coming to open this, my Linux, and then what I'm simply going to do is to make sure that I'm, okay, let me clear the screen first, then I come down. First of all, before you are able to use the Linux interface, you should know how to navigate within the Linux. So what I'm going to do is I downloaded it, and then let's come and check where the file is being. So go to your desktop, and this is the file that I just downloaded. So you can see it is here. There were just about 8 of them, and as you can see, that's all of them. So what I'm going to do, I think the name was just too long, so what I'm going to do is I'm just going to rename it. And in renaming, I'm going to, it's actually an HIV virus, so I'm going to say HIV, what is it, HIV3 dot faster. So when you do that, you click enter, and then the file has been named. But you see that it is found in downloads. So when I go to my terminal, if I open my terminal like I have here, I need to make sure that I am working in the directory where the file is being kept, and that's the download directory. So I'm going to say cd into my download directory. But you know, I am working on Windows Ubuntu terminal. So the way you navigate to your downloads is a little bit different from when you were working on Ubuntu terminal. So here you have to make sure you pass through the media like this, and then you go through C, go through your user interface, and then go through your own name. That's how your computer was configured. Then you add downloads, of course, and then so now my current working directory is downloads. So if I want to view that particular file I just downloaded right now, I could just say the head, and then I want to look at just 10 lines. So I'm just going to say 10, and then the file name is HIV, and then I added 3 dot faster, then it will complete it. So this is the first 10 lines of that particular file. So it tells me that the file is already found within this current working directory. So the next thing is to simply now do the alignment. So I'm going to, I've already got what is it? So this is basically the code that you can use to be able to do the alignment. But before this code, you should know that this is the function that we are using to do the alignment, which is called the package, which is called the cluster. So, and the cluster, what you normally would do is, okay, so let me explain this a little bit. I'm just going to copy that, And so what we do is, so if I come here, you could just do cluster load. If you are not conversant, you say this, then health, then that gives you all this information about how to use the package called cluster load to do your multiple sequence alignment. So actually you have to scroll up to the usage. So this is where the usage is. So you have the cluster load followed by this I here, which indicates, followed by the file where you have kept your sequences where you want to do the alignment. You could ignore this flag. If you want to know what this flag means, come and look at what I here means. You can use I or dash in. It means that that's your input file, and then that's it. You can see the input file being what here. Of course, you could also have your output file also by what is it? Also flagged with O. So if I go back to, so if I am here, let me, so I can just say I have my cluster loop like this. Then I have my dash I, then followed by the file. What's the name of the file? The file was I have 3.faster. That should be able to complete it. And then I bring something like dash O. That's my output file. How do I want my output file to look like? I'm going to say my output file should also be hiv3. Let's say in this case is okay. I can just put that align dot faster. Now I am saying that I want my output file to be in a faster file format. And what kind of output am I expecting? I'm expecting an alignment output. That's why. And what file is it going to be called? It's going to be called hiv3 alignment file. That will be my output file name. So when I do that, that's all. I can just put enter, and then Clusterlo will do the alignment for me. So the alignment is complete. And so the next thing for us to do is to at least do what we call the matrix. The matrix means that you want the entire alignment to be shown, so that when you visualize it, you can have it. So you see, we use the same thing here, but instead of instead of having this O here to be O, that place, because you want full alignment, you put that place dot and say full. And then when you come here, instead of having this time around, you are not looking for the output file to be an alignment. You want it to be matrix. So I am changing the whole of that portion into matrix. So I'm just going to say matrix, and so I'll put that matrix 3 dot out. So that's what I want to do. So the file is going to be called matrix 3 dot out, and that's my full alignment. So when I do that, it tells me that there's an unexpected symbol argument here. So let me check what that means, and then I can simply get it right for you. Okay. Okay. So okay. So I can just come here, do the changes here, and I'll call this place hiv3, and then I think I need to change the output. What is the file, so that I can have something different. So I'm going to come here and just add here _1 or something like that, and yeah, and so that finished, because I've already got an output file called matrix.out, and that is why. So when I added a tree to it, it didn't understand, so I just put _. So that's going to be the file over there. So the next thing is to generate our guide tree. So I've already got the code here. What is it? All that I need to. So we are going to generate our guide tree, and with the guide tree, it's the same kind of format, but this time around we are going to say HIV 3.faster. So you see, in all the cases we have HIV.faster. That's the name of your input file, and here the output we are looking for is a tree. And so we are using the guide tree to be able to generate the output. So the output will be in the form of a tree. So we are saying that our output should be a tree, but we've already got this tree there. So what I'm going to do is I need to generate a different tree. So maybe I should put this one H tree at least. That way it will say that it will be different from the other trees we have already generated. And so when I do that, I just enter, and you can see the process is complete now. So if the process is complete, means our entire alignment has been done. Now let's go and have a look at how the alignment will look like. So obviously you can even list any of them here. You can list and find out, but I have a lot of things under my my downloads. So when I list, you're going to find plenty things, as you can see. But if you check, all the files will be there. Obviously you can see the H tree. You can see the trees I've generated so far. Some of them are here, but I'm looking for H tree, the guide tree. It should be somewhere under H, so you can see that particular tree is here. And then we also had some matrix. What is it? Matrix 1. That was also the output file we generated. And we also had the HIV in caps. So if you look at, if we go up to the caps section, we're going to find that particular file to somewhere. Which is here, HIV3.faster. So all the files we generated are all here. The next thing is to now visualize those files. And so I'm going back to my Windows. As you can see, the files are here. The HIV3.faster is here. Then the matrix underscore 1 out is also here. And then the H3 weak file is also here. Now let's visualize them and see how the clustering will be done. So to be able to do that, you can either do the visualization using Uniprot Eugene, or you can do that at any of the online versions, like Center for Genomic Epidemiology. You can have those services provided there. So I'm going to minimize this and get to my desktop, and then open up my I was doing a lot of things. So I am here on my desktop. So you can see this is my Unipro Eugene. If you don't know how to get this, try to download it. Just go to your Google and say what is it? Uniprot. You have your Uniprot Eugene download. So you can see the download here. So it's going to send you to the link. So you can just come here, download it, and then you run it as an administrator. Click next, and everything will be downloaded. And so when you download, you're going to have it on your desktop, like I have mine here. So I'm going to double click and launch it. It's opening right now, so it is ready. So now when I go back to I can now pick this particular weak file, that the file that I generated during the alignment, to be able to view the actual alignment, how it was done. So I'm just going to minimize this, and then I can just go through and check where my weak file is. It was h3.nuweak. The file is here. So I'm just going to drag it and come and drop it in the open space here. And then you see that the alignment, this is how the alignment looks like. And this was the reason why we edited the names. So you can see this is the first genome, or the first sequence, the second sequence, all the 8 sequences are here. And then this is how the alignment looks like. So you can check the alignment of all the positions. You can see gaps are there and whatsoever. Now, if you want to have, so this is our alignment, which is quite easy. So we can now read, we can see the conserved regions, we can see there are places where there are deletions and there are gaps and whatsoever. And we can check for all the positions. You can always come down here, click in one of these places, and you see the kind of alignment that is there. These are bar graphs actually showing us the distribution of the alignment down there. We could now the next thing is, how do we do the clustering? Now that we have the alignment and we're on this interface, we can actually do the clustering. It's quite easy. So to do the clustering, come and check all the icons on top here. You see this like a tree, you see that build tree. So that's where we can actually get our clustering. So I'm going to come here, click on this box, the gamma distributed rates, and then come here and then build. So that is going to build me a tree. The tree has been built. All I need to is to simply come and do some rectangular. Maybe I want it in a circular form, so I could fit it. I'm just trying to. So the clustering is here. So as we can see, we can do some bit of editing here to make it look a little bit. What is it? So we can see the clustering here. This is a circular format. We could actually come here. We could actually come here and look at the unrooted, and then you see how it has been clustered. This one, we just pick them at random, and that's why they look the way they are looking. If we wanted to actually format, we could come here, do all sorts of formatting that we wanted. We just come and do like this to change the text, color, and whatsoever. If we can remove the distances which are here, these numbers you are seeing are the distances. So maybe I don't want the distances to be shown. I can just click here and come and say I don't want them to be shown, and then they will all be out. Or if you want to, okay, then let me come back over there. What about if you want a cladogram? This was the phylogenetic tree. So now let's look at how the clustering would have looked like. So this is how the clustering would have looked like. Let me take out the distances, and then this is how the clustering would have looked like. And so you have your clustering. You can also look for your phylogenetic tree by simply just clicking here. And when you come to this place, you select the phylogenetic tree, and then so that's the phylogram, and it will generate your phylogenetic tree for you. So if I do that, that's going to happen. I could use a different approach, and then of course I can come here. Maybe I want the rectangular form. So this way we can see that our let me try and see what if I can reduce it. It's quite small. They are just 8 samples. That's why you're not seeing the pattern. If it were a different one, let me pull up this. I have one that is a little bit bigger for you to see. This was simply to let you see how we are able to generate some of these trees. Okay, so there is. Let me open this wide and see. Okay, so there's one here. I could actually check for that one and see how that will look like. Let me reduce the size and then pick a different tree, and then you see what maybe you will see. Okay, so now this is a different tree that I generated earlier. So you can actually see how the clustering is done. So let me come here and click, and then you see how it is being done. So this is your phylogenetic tree, but we can actually also look at the clustering by simply just going to cladogram. This is the phylogram. So I'll come here for the cladogram, and then I click OK. And then, of course, I need to come here and say I want it in this manner, of course, and I want it fits. So I'm coming here to click this to make sure I have it fit. Okay, but the font size look a little bit smaller. I can actually increase that by doing some level of formatting here. Just increase the font size to some few, and then remove these distances around here. Or maybe I could come here and then change it to unrooted. Well, so here what is now left is for you to do your manipulations, and then you are able to get exactly what you want. Okay, I'm going to cancel this and just Yeah, so you can just use the phylogram to get your phylogenetic tree, and then you can also use the cladogram to get your clustering. And of course, if you are also interested in your alignment, then the alignment is also there for you. This is basically how we are able to do. So what is it? I'm trying to pull it back. Okay, so I just closed that particular panel. There are quite a number of the trees I have. There was one here. Yeah, so this also is like the immediate one that we just have. So that is how it is. You can now have your alignment. You can actually, print any of this out, or you can take it to your Word document, and you are able to provide whatever explanation that you want. You can see the gaps. You can see where there are conserved places, and all these colors and what they mean. You can check Eugene documentary site for more information as to how to interpret all this. But so this is how alignment is being done. Multiple sequence alignment on what is the line of? It's quite easy like that. Could have done this with any what should I say? You could have done it with any sequences like either DNA or RNA or whatsoever. It depends on your sequences, but the approach is the same, and that's what I wanted us to pay attention to. So I just come here. Yep. So I have this over here. So this font sizes, it can always reduce here. You can come here and reduce the font size. I think this is to somewhere 11, maybe it will be better. Yeah. So and that is it. So you can just slide here to see how the phylogenetic tree is. Just slide it this way. If you want it out, you just can come here. You can copy it as to your clipboard. You can also save it as a visible, and then you can also save it as an SVG, and then you are good to go. All these things here, we can just play with them, and then we can have our phylogenetic tree the way we want. So this one is simply to fit it, and then here it's to simply fit it to the window, and then that's how it is. So I can now copy it to any place at all that I want, and then you can see the distances around here. You can see those that are close are marked. If you don't want it in this format, you could as well change it to the circular format like we said earlier. So this is the circular format. If you don't want it, send it to the unrooted format, and then whichever way that you want, and then you are good to go. Yeah. Let me take it back to the rectangular format, which looks a little bit nicer for me in that context. And so that is it. So I have my alignment on one side, I have my clustering, and I have my phylogenetic tree. Okay, so the rest of these things that are here, they're just editing that you can just change them as and when you want. Change here, come, and then it's the same thing. So you can come have your rectangular whatsoever, and that is it. So that's your, by way of being able to do your multiple sequence alignment. This was on the, so let me just clear the screen. And so we first of all started by downloading our sequences and putting them on the download directory. So we navigated to the directory and we used this code first, this one. So we use the cluster load, -i means input, and then you add, this is your input file, add it to it. Come and indicate -o here means output file. Then you indicate how you want your output file to be. You want it to be in FASTA file format. So depending on whatever that you want, you might not want anything else, so you can leave it here. If you want anything else, then you could have, then the next thing is to do full alignment. The full alignment is when you use --full, then, and the out will be in the matrix form. So that way you have your matrix form. That way you may not have your guide tree. If you want to do clustering, you need to generate a guide tree using this particular code. And so the code will be like the same input, but here you use a guide tree, so that you want to generate the alignment in the form of a guide tree. So, and what's the name of the guide tree? I gave it the name H tree, but the extension might be NWK, that is in a week. And when you are done that, so the 3 files are now ready. You have your alignment in faster file format, you have your full alignment in the matrix form, and then you also have your alignment in the guide tree format, where you can use the guide tree in the weak file to generate either your clustering or your phylogenetic tree, and then you are good to go to see how the sequences have been aligned. So I think that will be your your video of today. And then thanks. I hope you've learned something small. Okay. All right. So bye bye.